So this one says, how many times larger is 9 times 10 to the 7 than 9 times 10 to the 4? Well, same thing, okay? That's going to be larger over smaller, larger over smaller, okay? And so the larger one's obviously going to be this one over the smaller one, which is this one, okay? So it's going to be 9 times 10 to the 7 means 9 followed by 7 zeros. 1, 2, 3, 4, 5, 6, 7, divided by 9 times 10 to the 4th, which is 9 followed by 4 zeros. 1, 2, 3, 4. Okay, we can cancel. And we get 9,000, right? We get 9,000 divided by 9, which is 9,000 divided by 9 is 1,000. Okay, which means this number is 1,000 times larger than this number. Okay? And we can look at this problem also. All right, number 20. Number 20 says the radius of the sun is about 900 million meters. Okay, 900 million meters. Okay, the sun. So maybe that's something worth writing down. Okay, so the sun is 900 million meters. It says the radius of the planet Venus is about 5 million meters. So we'll do Venus. It's going to be 5 million. Okay. And it says, after that it says, and the radius of the supergiant star Betelgeuse is about 800 billion. Okay. So we'll say Betel is 800 billion. Okay. And we're given a list of, and they're saying which of these statements is correct. Okay, so we need to go through these and we need to choose from the correct statement. All right. So the radius of the sun is about blank meters. The radius of Venus is about blank meters. The radius of the sun is about blank meters. Okay, so underneath all these blanks, okay, all these black marks is just a scientific number. Okay, it's a number in scientific notation, and it's not any number. It's the radius of each one in scientific notation. So all you have to do is go and find what these numbers are in scientific notation, which is very straightforward, and then just find the sentence that matches it right. Okay, so let's go ahead and do that real quick. 900,000 in scientific notation for the sun. Okay, so the sun. Okay, so the sun's going to be 900. 1, 2, 3, 1, 2, 3. We can call it 0.0, so we can see the decimal. Okay, if you want to do that, and then we need to jump 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we get 9 times 10 to the 8 meters. Scientific notation. Okay. Next one, Venus. Okay, Venus is 5 million. Okay, so we're going to put the decimal, 0.0, 0.0. We need to jump until we get this number to be in between 1 and 10, right? 1, 2, 3, 4, 5, 6. So we get 5 times 10 to the 6 meters. Okay, and the last one is Betelgeuse. Okay, which is going to be 800 billion. So 800. 1, 2, 3, 1, 2, 3, 1, 2, 3, 0. Okay, and let's see, we need to jump 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So we get 8 times 10 to the 11. Okay, meters. This is 8 times 10 to the 11 meters. Okay, and that's your answer. All right, so you just need to go through. So now that you have these in standard notation, you just need to go through and pick the right sentence and where you find it. Okay. And now we have this next problem, which has to do with the subtraction of numbers in scientific notation. Okay, so let's go ahead and let's go through 21. All right, so 21 says which of these is correct, and it's multiple choice, and it doesn't say select all that apply. So I'm pretty sure that means that there's only one number that's correct. Okay, so let's go ahead and let's go find it. All right, and I'm just gonna go through the list, and if I find one that's correct, I'm not gonna do the other two because I'm just gonna be confident that I did it right. Okay, so let's see. the first one that we're given is going to be 4.6, okay? 4.6 times 10 to the 5th power. 4.6 times 10 to the 5th power minus 2.1 times 10 to the 4th. Okay, and I'm going to do this the shortcut way that I like to do it. Oops, okay. 2.1 times 10 to the 4th. Okay, I'm going to do this shortcut way, how I like to do it, which means I like to jump real quick. So I'm going to get 46 times 10 to the 4th minus 2.1 times 10 to the 4th, right? I like to use one of my jumps so that I can have the 10 to the 4 to be the same number. So then all I'm doing is subtracting these two numbers from each other. Okay, so 46 minus 2.1. Well, 46 minus 46 minus 2 is 44. 44 minus 0.1 is 43.9. So we get 43.9 times 10 to the 4th. Okay, and if we take this as standard form, right, because the answer is in standard form, we get 43.9. We'll jump 4 times. 1, 2, 3, 4. 0, 0, 0, 0.0. And as you can see, we got 439,000, which is not 250,000. Okay, so that is not correct. Okay, let's go to the letter B. Okay, letter B says 8.8 times 10 to the 8. 8.8 times 10 to the 8 minus 6.2 times 10 to the 7. Minus 6.2 times 10 to the 7. Okay, so same thing. Let's go and see if it's equal to this. Okay, so 8.8 times 10 to the 8 is going to be, like I said, I like to move this decimal. I like to take off the exponent here. Okay, so I like to jump one. So I'm going to get 88 times 10 to the 7 minus 6.2 times 10 to the 7. Okay, so now that I have the same 10 to the power, now I can just subtract the regular numbers. Okay, so I'm going to do 88 minus 6.2. All right, 88 minus 6.2. Well, 88 minus 6 is 82, right? But minus another 0.2, you get 81.8 times 10 to the 7. Okay, 88 minus 6 is 82, but take away 0.2 from 82 and you get 81.8. All right, and we can see what that's equal to. So times 10 to the 7 means 1, 2, 3, 4, 5, 6, 7. Put in your zeros. So it's 818 with 6 zeros. Okay, and we can put in our commas. And we get 818 million. All right. And that's what it says here. Okay, so we select this one, and I'm not going to do these other two, okay, or these, because I already know this one's the answer. All right. And we have and so here are these last few problems, okay? Very straightforward. Express the number in scientific notation. All right? Very straightforward. Okay? Okay, so here we have these last few problems, all right? And it just says express the number in scientific notation, all right? And the number is right here, so it's 0. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros with 3, 7. We want scientific notation, so we need to jump until we get a number between 1 and 10. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we get 3.7, right? We stopped here, times 10 to the negative 11. That's it. You're done. Okay? Problem's over.